Dear students, today we will be discussing about the inverse of a matrix. So far we learned the addition of matrices, scalar multiplication of matrices, then multiplication of matrices. Today we will be discussing about the inverse of a matrix. Now let A be a square matrix. A is a square matrix of order n. A is a square matrix of order m. Suppose there is another matrix B of the same order. Order is important. If there is another matrix B of the same order such that the product AB equal to I, the identity matrix equal to BA. If there exists a matrix B such that the product of these two, we are getting the identity matrix. ऐसा एक मैट्रिक्स B है तो कैसे होना चाहिए? ये दोनों का प्रोडक्ट आइडेंटिटी मैट्रिक्स आना चाहिए. If there is such a matrix, then we say that A is an invertible matrix. A is an invertible matrix. If there exists a matrix B such that AB equal to I equal to BA, then A is said to be an invertible matrix and B is called the inverse of A. B is known as the inverse of A and is denoted by A inverse. This is the symbol for the inverse of A. Then what it means finally? That is A into A inverse equal to the identity matrix equal to A inverse into A. This is the property of the inverse of a matrix. We can see here also. Invertible matrices. A square matrix A of order m is said to be invertible if there exists a square matrix B of order same order m such that AB equal to I equal to BA. You see that? And the matrix B is known as the inverse of A and is denoted by A to the power minus 1, that A inverse. That in the trigonometry also we know as sine inverse, the function of inverse, F inverse. Like that here, the inverse of A is denoted by A inverse. Then what is the inverse? Once again you come here. Inverse means if the product of two matrices, we are getting the identity matrix, product of square matrices, if you are getting the identity matrix, then one of them will be the inverse of the other. The one will be the inverse of the other. Then the one property is there, 2, 3 property we are going to study. The first one is the inverse of a matrix is unique. Unique in the sense we don't have more than one inverse for a matrix. If A is any square invertible matrix means it will have an inverse. If A is an invertible matrix, then if it is inverse is there, then there is only one and only one inverse is there. Now how we can prove this? We suppose that there are two inverse B and C for A. Suppose, if possible. We are going to prove that it is not possible, but we are supposing that if possible, let B and C are two inverses of A. Then you see what happens. If B is the inverse, then what will happen? If B is the inverse, then the product of A into B equal to B into A equal to I. In the same way, since C is the inverse, what we can say? The product of A and C, AC equal to CA equal to that also equal to I. Since B and C are both are the inverse of A. Then you see, B can be written as B into I, no issue. I can be written as A into C since C is the inverse AC side. Therefore B into AC, then we know the associated property of multiplication, then it is again equal to BA into C. But BA is again identity matrix since B is the inverse of A. That is I into C equal to C. What it means? It means that B and C are same only. We don't have more than one inverse for a matrix. Therefore, understand that if there is an inverse, then it will be unique. We cannot find more than one inverse for a invertible matrix. Now, one more property we are discussing is, what is the inverse of AB? What is the inverse of AB if A and B are invertible? Inverse of AB. A and B are two invertible matrices. Then how we can find the inverse of AB? What will be the property of the inverse of AB? The property will be like that. If we multiply AB with a matrix, then we should get I. If you take the product of AB and another matrix, then if you are getting the identity matrix, then that will be the inverse of AB. Now we are going to prove that the inverse of AB is nothing but B inverse into A inverse. The inverse of AB is B inverse A inverse. What it means? It means the product of this matrix and this matrix, we should get I. If the product of these two matrices is the identity matrix, then the inverse of AB is B inverse A inverse. That is here. You see, one second. You please come here. If A and B are two invertible matrices of the same order, then the inverse of AB is B inverse A inverse. That is, AB inverse is B inverse A inverse. Therefore, that what we are going to do? We are going to take the product of these two, AB into B inverse A inverse. Associated property, we can combine these two. B into B inverse, since B inverse, then we will get I, then A into I. A into I is again A inverse, that is I only. Therefore, the product of these two matrices is the identity matrix. In the same way, we can prove the other one also. Both way we can prove. Therefore, it means the product of these two matrices, we are getting the identity matrix. It means that the inverse of AB is this matrix. That it is regarding the inverse of a matrix. AB is B inverse A inverse. Now the next step, what we are going to do is how we can find the inverse of a matrix. Suppose matrix, okay, what is the inverse we understood. Now how we can find the inverse of a matrix? There are two methods. One method is the method of elementary transformations. Elementary transformations, or we can say elementary operations. Elementary operation or elementary transformation. By the method of elementary transformations, we can find the inverse of a matrix. Now, first we will see what are the elementary transformations. There are 6 elementary transformations are there. 3 are for rows and 3 are for columns. We will see what are the row operations. What are the operations we can do on rows? The first one, you see, there are 6 elementary transformations of a matrix. Transformation can be read as operations also, we can use the same meaning only. There are 6 are there. First 3 are, we are taking only row operations. The first one is the interchange of any 2 rows of a matrix. The interchange of any 2 rows of a matrix. Second one, the multiplication of the elements of any row by a non-zero number. The multiplication of any row by a non-zero number. The third one, the addition to the elements of any row, the corresponding elements of any other row multiplied by any non-zero number. Sentence is quite big for you. The addition to the elements of any row, the corresponding elements of any other row multiplied by any non-zero number. It is nothing, it is not so that much, it is simple. You can see here, if you are writing an exam, suppose 1, 2, 4, 0, minus 3, 8, 5, 7, 6. Suppose this is a matrix, square matrix. The first one is interchange of any 2 rows. If I am applying the first row operation, I am interchanging R1 is interchanged with R3. It means the first and third rows are interchanged. Then what will happen to this matrix? If you are interchanging the first and third row, the the matrix will coming. The third row will come the first. 5, 7, 6. There is no change in the second one. 0, minus 3, 8. Then 1, 2, 4. This is the first operation. Interchange of any two rows. What was the second one? Second one is the multiplication of any row by a non-zero number. The multiplication of any row by a non-zero number. What is that? Suppose I am doing the second row is replaced by 5 into R2. R2 is replaced by 5R2. Then what will happen? You see, that is first row no change. 1, 2, 4. The second row is multiplied by 5. It is replaced by 5 into R2. That is 5 into 0, 0. That is minus 15. Then 40. Then 5, 7, 6. This is the second operation. Second operation means the multiplication of, this is the first one, interchanging. Second one, if you are changing any row by the multiple of any row, if you are multiplying by a scalar. The third one, the addition that you see, the addition to the elements of any row. The addition to the elements of any row by the multiple of another row. Suppose I am changing the first row by first row plus 2 times second row. Such operations. Addition of any elements of row by a non-zero multiple of any other row. That is simple thing. What I am going to do is first row is replaced by first row plus 2 times R2. 2 times 2 into 0 is 1 plus 2 into 0. That is 1 only. Then 2 plus double of this is minus 6. 2 plus minus 6 minus 4. Then 4 plus 2 times R2, that will 16, that is 20. That first row is replaced by first row plus 2 times R2. Second, there is no change. 0, minus 3, 8. Then 5, 7, 6. These are the 3 elementary row operations. It can be minus also. Minus 2. Any number we can change. Once again, I am reading that. You see. The interchange of any two rows of a matrix. Interchange of elements of row. Second, the multiplication of the elements of any row by a non-zero number. Multiply any row, we can multiply replacing that by a non-zero number. The third one, the addition to the elements of any row, the corresponding elements of any other row multiplied by any non-zero number. एक रो के साथ एक नंबर से multiply करके दूसरे रो के साथ ऐड करना. These are the elementary row operations. Now, in the same way, we will have column operations also. What are the column operations? In the same way, the interchange of any two columns of a matrix. The interchange of any two columns of a matrix. Second one is multiplication of the elements of any column by a non-zero number. Third one is the addition to the elements of any column, the corresponding elements of any other column multiplied by any non-zero number. एक कॉलम के साथ एक नंबर से मल्टीप्लाई करके दूसरा कॉलम के साथ जोड़ के लिखना. These are the 6 elementary transformations. देखो, the thing is why we are going to study these operations. That's most important. Therefore, that we will see the next also. Working rule for finding the inverse of a matrix using elementary transform. We started with the inverse of a matrix. Now we are discussing how we can find the inverse of a matrix. This is the working rule. Let A be an invertible matrix. Then A can be written as I into A. No issue. Then apply a sequence of some row operations. Same operations we should apply on the both sides A and I to bring the equation to the form I equal to BA. Then the matrix B will be the inverse of A. The same operation can be run on column also. First we will come here, then we will explain. I will explain once again. using elementary operations how we can find the inverse of a matrix. Now, suppose A is an invertible matrix and we have to find the inverse of IA. Then A can be written as I into A. Now we have learned 3 row operations and 3 column operations, elementary transformations as we told. Now by applying row transformations on both sides, we apply some operations here. Here also, on I also we will apply the same operations. Suppose if you are interchanging, then here also we will interchanging. If you are multiplying a non-zero number, then that also we are doing on same side. Then this equation, IA will be coming to the I. That is our process. A will become I and this will transform into some B. It will be B into A. So that the product of AB, again we are getting the identity matrix. Then we can say this B is the inverse of A. These operations can be done either by row operations or column operation. In a single problem, we will be applying either row operations or column operation. We cannot apply both of them. Now, one example we will see how we can find the inverse of a matrix. Suppose a simple question I am doing. Find the inverse of 1, minus 1, minus 2, 3. We have to find the inverse of the matrix 1, minus 1, minus 2, 3. Now this is our A. Therefore this matrix can be written as 1, minus 1, minus 2, 3 can be written as identity matrix 1, 0, minus 2, 3 into this. So this identity matrix 0, 1 into that matrix A. This is our A only. This is our A matrix. Now what is the method told? We will apply some elementary transformations on this side to bring this matrix into the identity matrix, and the whatever operations we are doing, that we will do here also. Then here already identity matrix, this is a form of identity matrix. We have to bring in that way. Therefore, here already one, no issue. Now what is the next step? Here we have to bring 2, 0, 1, 0. For that, what we have to do? We will be doing this operation. You see, you just think the second row is replaced by second row plus 2 times first row. You see, if you are multiplying here by 2, then 2 will come. Then 2 plus minus 2, here 0 will come. Therefore, the first operation we are going to do is the second row is replaced by second row plus 2 times the first row. That is, first row there is no change, 1 minus 1, then minus 2 plus 2, minus 2 plus 2, that will become 0. And here 3 plus minus 1 into 2, 3 minus 2, that is 1, 3 minus 2 is 1 only. That is here what will, the same operation here we are going to do. R2 plus R2, first one there is no change. R2 is changed to R2 plus 2R1. 0 plus, it is 2. Then 1 plus 2 into 0, that is 1 only. Into A. Now, this already now. This is the form of identity matrix. Here there is 1 only. Then this we have to bring to 0. Therefore, what we are going to do? If R1 is replaced by R1 plus R2. R1 is replaced by R1 plus R2, then what will be going to happen? 1, then this will become 0, then again 0 and 1. Here it will be R1 is replaced by R1 plus R2, that is 2 plus 1, 3, 1 plus 2, 1, 2, 1 into A. Therefore, what it means? A into this matrix, we are getting the identity matrix. Therefore, this matrix, this new matrix will be the inverse of a 3, 1, 2, 1. 3, 1, 2, 1. This is the inverse of the matrix. This simple method only. First you write the given matrix into I into A. Then do some elementary row operations to bring the left side identity matrix. The same operation we are doing the right side also. Then we will get the inverse of the given matrix. We can do problems in the next session. Thank you.